AP Calculus AB, Notes 1.4, Limits of Exponential Functions. Consider the four exponential functions graph below. Find the indicated limits for each function based upon the graph. So hopefully you recall from pre-calculus the importance of these exponential functions. One of the restrictions that I gave you folks was to make the base of this exponential function always bigger than 1. So this is 2/3, which is between 0 and 1. To make this 1, we have to make it bigger than 1. We got to reciprocate this. When that happens, we negate the exponent. So I would prefer to see us write it as 3/2, and then negating the exponent like so. Just a quick review of what this means. The base is obviously 3/2. The parent graph looks like this. This negative here is a horizontal reflection, so that's why the graph looks like this. And this -2 translates the graph to the right. I'm sorry, this -1 translates the graph to the right one. This -2 translates it down 2. So that's why there's a horizontal asymptote at -2, because of this. And normally the point we keep track of is the 0, 1, which is here. But since we are moving this to the right one and down 2, that point becomes right there. So some things we did in pre-calculus, if there is a horizontal reflection, that means as the graph approaches infinity, it's going to be approaching the horizontal asymptote. I think that you folks remember that. So anyhow, this limit here, once we can see the graph, it's super obvious, and this is explaining how we know what the graph would look like if you weren't given a graph. What's the limit of f of x as x approaches negative infinity? Well, as we go left forever, it's going up forever, so it's going to infinity, which means it does not exist because it's not a number. As we move to the right, it's approaching this horizontal asymptote of 2, negative style. Let's look to the right here. So this is between 0 and 1. I'm sorry, this is bigger than 1, this base. The exponent doesn't have any reflections. There's no vertical reflection out here. So this is the same end behavior as the parent graph. Yes, it moves to the left 2 and it moves down 2. Moving to the left 2 is not that important to us. Moving down 2 is. It tells us where the horizontal asymptote is. As x goes to the left forever, what's happening to the function f? Well, it's going closer to the horizontal asymptote. That's the left end behavior. As x goes to the right forever, f of x is approaching infinity. That means this limit does not exist. Let's check out this fourth one. Once again, I don't like the fact that this base is less than 1. So I'm going to strongly encourage you to reciprocate that. When you do that, you negate the exponent. So if you recall what happens here, this is a vertical reflection. That means it's below the horizontal asymptote. It's from pre-calc. And this here means that it is a horizontal reflection. So it's growing towards the horizontal asymptote, is what that means. Recall that if there are 2 reflections, an even number of reflections, then it's still growth. So as this function goes to the left forever, this function is approaching negative infinity. It means the limit doesn't exist. As this goes to the right forever, it's approaching that horizontal asymptote of -1. Last scenario, we'd like this base to be bigger than 1. I reciprocate the base. I negate the exponent. That's going to make this x minus 3. This has a vertical reflection, no horizontal reflection. If it's a vertical reflection, you'll recall, it means the graph is below the horizontal asymptote. If there's only one reflection, it's going to be a decay. It's an odd number of reflections. It's something from pre-calc that hopefully you remember. We're going to the right 3 and up 2. The up 2 matters. The right 3 doesn't matter in this context. As we go left forever, the function's approaching the horizontal asymptote. As we go right forever, the function is approaching negative infinity. It means the limit doesn't exist. These four graphs, as a whole, we have examined every scenario for an exponential function. We've examined one with no reflections. We've examined one with only one horizontal reflection. We've examined one with a vertical and horizontal reflection. We've examined one with only a vertical reflection. So all that being said, in order to determine a limit as x approaches negative infinity or infinity for an exponential function, the only choices we have up above, you have to determine what the graph will look like. Based on what you've seen above, what are three possible results for these limits? Well, it could approach negative infinity, it could approach infinity, or it could approach the y value of the horizontal asymptote. Those are your only choices. By studying the graphs above, remind yourself of the parent graphs of the exponential function and the transformations. If you want to take a moment and go back and look at your notes for exponential functions and write down what we summarized in pre-calculus here, I would highly recommend that. Me doing it for you is a disservice for you. Learning happens when you can take something that you've learned new and apply it to old things, and me telling you these things, I am robbing you of that learning opportunity. Determine the limits of each of the following exponential functions. So what I would do for this is what I would do in pre-calc. I would make sure that this is bigger than 1. So I would rewrite this as the limit as x approaches infinity. This is the right end behavior. We got 3 over 2. That's going to negate the exponent. So I change both signs. So does this have any reflections? No. It does have a translation down 2, so that means that my horizontal asymptote is at y equals negative 2. No reflections, so it's a growth function above the horizontal asymptote. So what's happening as we go to the right? It's going to approach infinity, which means this limit does not exist. Check out this little fella right here. This base is less than 1. Reading this properly would be 4/10. What's the reciprocal of 4/10? Well, that's 10/4. Good, buddy. So I could write this as 10/4, negate the exponent. So hopefully you'll recall, this is a vertical reflection, so it's below the horizontal asymptote. This is a horizontal reflection, so it grows towards the horizontal asymptote. So if it's below and grows towards, it's going to be like this. And the last thing that we need to figure this out is, where is the horizontal asymptote? It's at y equals negative 4. So as x goes left forever, what's happening to this function? It's going down forever. It's approaching negative infinity. That means that does not exist. Even though it does not exist, you have to write negative infinity or positive infinity? You do. You need to write it. If you don't want to write does not exist, that's cool, but you do need to write the negative infinity. Here's another one. This base is not bigger than 1, and we'd like it to be. So we could write this as the limit as x approaches infinity of negative 3 over 2. I'm going to negate the exponent, so that's going to be x minus 2 plus 3. If you recall, this is negative. It's a vertical reflection, so it's below the horizontal asymptote. There's no horizontal reflection, so therefore it is growing away from the horizontal asymptote. So it's going to look like so. And if it is like so, this horizontal asymptote is at y equals positive 3, because this shifts it up 3. So as we go right forever, it's going to negative infinity. Number 4, Hey, this base is already bigger than 1. Please keep in mind, order of operations. You do 2 to the exponent, then you apply the negative. Oftentimes, to emphasize this, I'll put this in parentheses. You don't have to. So what's happening here? Well, this is a vertical and horizontal reflection. So that means it's below the x-axis. I'm sorry, it's below the horizontal asymptote, and it's growing towards it. This makes it below, this makes it grows towards it. All stuff that we have studied extensively in pre-calculus. This translates the graph up to, so the horizontal asymptote that was normally at 0 is now going to be at 2. So as this function goes to the right forever, it's getting closer to the horizontal asymptote, which is 2. Number 5, e is 2 point something, so it's already bigger than 0. This negative makes the curve grow towards the horizontal asymptote. Still above because there's no vertical reflection. This horizontal asymptote is at y equals 2. As we go left forever, this graph is going up. It's going to infinity. That limit does not exist. Number 6 has got 4/10 in her again. I'd like to rewrite this so that the base is bigger than 1. If I reciprocate the base, I change the sign of the exponent. So this means the curve is below the horizontal asymptote. This means that it grows towards it. So below and towards is going to look like this. And as we go to the right, we are approaching this horizontal asymptote of y equals 4. 7, base is bigger than 1. Don't be fooled here. This, oh, wait a second. I just got fooled. Let me take a moment and take a step back because I was just too into a groove, a foolish groove. Question 1, x is approaching infinity. 2, negative infinity. 3, infinity. 4, infinity. 5, negative infinity. 6, infinity. These are all talking about end behavior. Number 7 asks no such thing about end behavior. We can just use direct substitution for this. This is going to be e to the 2 minus 3 plus 2. It's going to be e to the negative 1 plus 2, which we could write as 1 over e plus 2. Number 7, x is approaching negative 2. There's no reason why we can't just substitute this in. So we have a 1/2 to the negative 2 minus 3. A negative 2 is a plus 2. Plus 2 minus 3 is a negative 1. We could reciprocate this because of this negative and make it 2 to the first. 2 to the first plus 3 is 5. There you go. Hopefully that wasn't too difficult for you. Please do the homework for one.